Okay, this is the second week of the Data Science for Engineers course, and these are the highlights. So it starts with metrics and introduction to metrics, independent and dependent variables, solving linear equations, geometric view of linear algebra, eigenvalues and eigenvectors. So based on these topics only, you will be having the assignment questions also. So for that we will see some basic things and then we will move on to the questions, so that the theory which is left we'll do with the questions. Okay, so metrics means organization of data into rows and columns. Rows will be denoting the samples and columns will be denoting the variables or features. For example, is a biomedical data set of 1000 patients. Okay, so it's an example. So there will be a serial number with number of rows like 1 to 1000, then weight, height and age will be there. So these are the different, this is the representation of a biomedical data set of 1000 patients. Okay, now independent and dependent variables. So independent variables are variables that store unique information. Dependent variables are variables that are formed by the combination of already existing variables. So here I had shown a data set containing serial number, weight, height, age, and then there is BMI also. So BMI is something that you can create from the other things, like for example, like BMI can be given by weight by height square, like that. Like that you can represent it, right? So so here you can see, like, wait for so with that relation, okay, with that relation of BMI with height, I have formed a new column. Okay, so this column is having some relation with weight and height columns. That's why we can say that BMI here is a dependent variable, because it's a variable formed by combination of already existing variables. Now let's move on to the next one. Rank and nullity. So rank is number of independent variables or samples, and nullity will be the number of linear relationship. Okay, so nullity plus rank will give the total number of variables in a matrix. So for example, for this particular matrix A, the number of variables will be 3, then rank of A will be like 2 here, because you might have studied many of the ways by which you can see which is the how to find the rank of a matrix. One of those things is like to see the determinant of A. Okay, so like for example, here if you find the determinant of A, it will be coming like what will be the value of the determinant of A? Can you tell me?
में
Will it come like that?
I think 0.
Yeah. So yeah, everyone's staying 0. So just look at the rows. Okay, like one. Okay, so here you can see 1, 2, 3 and 2, 4, 6. These are 2 dependent columns, right? If you look at these two, like 1 into 2 will be 2, 2 into 2 will be 4, 3 into 2 will be 6. Okay, so these two are dependent. So since it's dependent, what will happen? If you calculate the matrix, it will be determinant of the matrix, it will be 0. Okay, and if you do some reduction, okay, row reduction or something, then it will be like you will be having one full row of or column of zeros. Yeah, then if you have, if at the first stage itself, if you look at the matrix and see that there is some dependency, then the rank of the matrix won't be equal to the number of variables. Okay, here is like if you are, so yeah, person has told like echelon form of matrix. So anyway, you can see the row echelon form of matrix, and if you find out that, you can see that one row will be coming like 0. Okay, so rank will be 2 only. Okay, so if the number of variables is 3 and then the rank of the matrix A is 2, then the nullity can be given like the difference of that, meaning like number of variables minus rank of A will be the nullity of A. Okay, so just this relation is there, nullity plus rank is equal to total number of variables. So we'll see the operations of matrices in the coming questions. Okay, so this is what is given. So first we'll move on to the first question of the last assignment problem. Okay, that means the last course which was run in July 2023. Okay, so are the vectors -2, 4, 7, -2 and 3, -6 linearly independent? Okay, I'll just give you a moment. You can just see whether it is linearly independent or not. Okay, I'll also start writing that. So Ravi has given no, I think, for this question, right? Yeah, Ravi has given no. Okay, so I'll just write for those. Yeah, many people are giving the answers. So 4, -2, -6, yes, most of the people are giving the answer. So if you give it like this, okay, just you can see if you take common from the first column. Okay, if you take -2 as a common from first column, it will be coming like 1, -2. Yes, everyone is giving the answer, so I think everyone understood. Anyway, for others I'll be just writing. And if you are taking like, just I'm writing. Okay, if you are taking -3 from the other one, from the other column, you will be getting like 1 and sorry, here it is +2 only. Yeah, and here you will be getting like 2. So if you just, here you can see these two are dependent, right? So that itself proves that they are linearly dependent. So these vectors are not linearly dependent. -2 in the third column, ma'am, in R2 we cannot have more than 2 linearly independent columns. Meaning like, Ravi, what did you mean? Here we have 3. No, then we will be saying whether it will span R2 or not. These are like two we are just checking, okay, whether these 3 are dependent or not, whether these are linearly independent or not. L1, 2 linearly independent vectors can span the entire R2 space. That is true. Yeah, that is true. So anyway, first at the first thing itself, you know that it can't span the entire R2 space, or otherwise you can just see like this also. Okay, now does the set, so this will be like the answer, does the set 1, 1 and 1, 2 span R2? Yes, so third will be dependent. So this one, okay, so this one also, just if you see, if these two things, it will be looking like S equal to wait a moment, S, so S equal to 1, 1, it will be coming like that. So if you want to solve the whole thing, like from starting to see how whether it will span R2 or not, the whole procedure is like, first you have to give a linear combination of these two vectors. Okay, so right now it's like 1, 1, 1 and 2. Okay, so what you have to do is you have to check A into 1, 1 plus b into 1 2, and you name it to some vector x comma or x or y. Okay, yeah. So the one of the things that immediately that you can do is like check whether they are linearly dependent or linearly independent. Okay, right now they are independent. Okay, so from that itself you can see, but the whole thing is like first you have to give it like this, and then you have to find the values for x and y. Okay, so this is like it will be coming like this, right? Then you have to reduce it to the row echelon form. Okay, so the operations that can be done here will be like r2 giving r2 minus 2 r1, and then if you do r2 giving r2 by minus 1, like that if you do, you'll end up with just I mean you can check these also, just I am fast forwarding through the things actually. So 1 1 x and minus 1 0, y minus 2 x you'll be getting. Okay, so these operations are done here. Okay, r2 is given by r2 minus 2 r1 and r2 given by r2 by minus 1. Okay, like that I did, and I got, sorry, this is plus 1 1 x and 1 0 y minus 2x by minus 1. Okay, two steps have combined and done. Then so here you can see it is like 1 1 and 1 0. Then again if you do like r1 given by r1 minus r2, if you do, then it will be coming like 0 1 and here x, then 1 0. Okay, I'm just reducing it. Okay, and here it will be like sorry, x plus y minus 2x, and here it will be 2x minus y. Then I'll be swapping these two, r1 swapped with r2, then you'll be getting like 1 0 2x minus y and 0 1 x plus y minus 2x, meaning like y minus x. Okay, like this it will come. Then what we will do is like we will substitute it to a and b, a equal to 2x minus y and b equal to y minus x, like that we will take. And then if we give these values to 1 by and 1 1 plus b y minus x to 1 2, then we have to see what we will be getting. So if you just solve this one, you will be getting like x y. So this solution can be obtained. Okay, so in this case you can say that these both will span R2. Okay, so one immediate way to say that is just to find whether they are linearly independent or not. So this answer will be A. Okay, it spans R2. Any doubts?
No, ma'am.
Okay, so then the next one is like, so next question, consider the following system of linear equations of the form ax equal to b. Which of the following are correct? These two are asked. So the system of equations given are these. Okay, now here first we can check for the condition, because in the solutions you can see ax equal to b given, and then ax equal to 0, ax equal to 0. So if they are independent, they can span R2. Yeah, that you can tell. If you have to check it like this, you have to like the method I have given, you can check it with that method. Okay, then what is, yeah, so 2x minus 3y plus 6 is x. So in this one I will write like this, 2, minus 3, 6, 1, 1 and minus 2. Okay, first we will check for ax equal to 0. Okay, first we will check for ax equal to 0. So in that one it will be like this into x, y, z equal to 0. So for solving that, I'll be writing like 2x minus 3y plus 6z equal to 0 and x plus y minus 2 z equal to minus 3. Someone has already given the answer. Anyway, I'll be getting here like, if I solve this one, okay, I'll be getting like y equal to 2z. Okay, so I think you are having these questions in your present assignment also, right? So anyway, yeah, so I'll be getting it like this, and if I substitute in the equation, in equation 1, 2x minus 6z plus 6z, it will be coming. So in anyway, like if you solve it, you will be getting like x equal to 0. Okay, and then y equal to, so you have got y and y equal to 2z. So in this solutions you can just check here, and you can see here like x equal to 0 is coming, and then z equal to 1. If z equal to 1, then y equal to 2 into 1 is equal to 2. So this solution is all right. Okay, then next thing we'll be looking at ax equal to b. What is the case for ax equal to b? And for that we will be solving with the given equations. Okay, 14 and minus 3. So that will be like so ax equal to b form. Okay, so that is like you have to solve these two, 2x minus 3y plus 6z equal to 14 and x plus y minus 2z equal to minus 3. So solving this equation, solving these things, you will be getting like can you tell me the values that you are getting? If I should go through the steps, it's like 3y plus 6z equal to 14, and then I have to make these two similar or something. Okay, so either, and this you can find in your calculators also, solution can be found out. Anyway, if you solve this one, so just the normal method, I mean the basic method if I am using, so I'll be getting like so this is minus 6. So I'll be solving this and I'll be getting like y equal to minus, is anyone solving this one? Okay, I'll get in this way, and then I substitute this one in case of y. That means equation like equation 1. So I'll just skip these portions. So 1 becomes, ma'am, I just substituted in the, yeah, that you can do, yes, but in case if you are asked to solve an equation, then just I am telling. Okay, so 2x minus any equation you can take. I think it's better to take the second equation. Okay, second equation, if you give, then it will be like x minus 4 plus 2z minus 2z equal to minus 3 will be coming. So x will be coming like x will be coming like minus 3 plus 4 equal to 1. So one of the options you have got, so you can give it like this one. Okay, so these are simple things only. Now, okay, So in solving the next question is in solving the system a equal to b in the variables ax equal to b in the variables x1, x2, x3, x4 by the Gaussian elimination method on the augmented matrix A augmented B led to the following row echelon form. This one, okay, this one is the row echelon form obtained. So just those who are want to know what this is, like the first entry which is coming as a non-zero number, before that 0 should be coming. Okay, so here the first entry, before that these zeros are coming. Okay, and okay, I have kind of written the answer also, so but just you can look here. So in this one the first row is like 1 0 0 3 2. That's okay, this is like the augmented matrix. So okay, Ravi, you are answering for the first question, right? Yeah, okay. So here you can see there in the second case, in the second variable, for the second variable also it's like 0 1, that form is correct, the echelon form is correct. In the third one, in the normal echelon form, here it should have been 1, and here also it should have been 1. Okay, or another way you can say like the last row is coming like all zeros. Okay, so it is like in row echelon form, the first non-zero entry in each row, if there is a 1, is a 1, sorry, it's a 1. Okay, and the column it is in corresponds to a leading variable. So these are all leading variables. The first one is a leading variable, the second one also corresponds to a leading variable, the third one here it should have been a 1. Okay, but instead of it 0 is coming, so there is not a leading variable there. Okay, so here also this is a, yeah, and in this one the fourth row, okay, so one of the variables is not having a 1. Okay, so essentially that which the columns that doesn't have a leading variable will be given as a free variable. So looking at the A augmented B matrix itself, we'll know that there is a row of zeros, so anyway one of the variables won't be having won't be a leading variable. Okay, so if the number of variables are 4 and number of leading variables are 3, then the other variable which is not the leading variable will be a free variable. Okay, so here from this one you can say that there is one leading variable. Okay, now which among the following is correct for the above system Ax is equal to B? Yeah, people are saying so this also it's like in the A augmented B matrix. Okay, if rank of A is equivalent to rank of A augmented B and it is equivalent to the number of variables. Okay, so here 4 variables are there, so all these are equal to 4. Okay, then it will be like unique solution. Then if rank of A equal to rank of the augmented matrix, but it is not equal to the number of variables, then it will be like infinite number of solutions. And if rank of A not equal to rank of A augmented matrix, then it will be like no solution. So the first part again, yeah, the first part again is like usually when you do, it is said like it is a row echelon form. Okay, this is a row echelon form. So row echelon form usually it should be like, so here there are 4 variables x1, x2, x3 and x4. So here just wait a moment. So here it should have been, so when you write the A augmented matrix and echelon form, the ideal case would have been like 1 0 0. Okay, 3 I'll include here. Okay, for since it's included there. The second thing will be like 0 1 1 2 3, here 2. Okay, this is the augmented matrix. And then the third thing should have been 0 0, so there should be like a triangular matrix forming. Okay, so here it should have come like this one, then some other number and some other number here, and next thing is like 0 0 0 1 and some other number here. So this is like some ideal case I am telling. Okay, ideal row echelon matrix. So yeah, okay Pavani, just I'm explaining the first part again. So here you can see that if it's coming like this, okay, so what I have written in here in the low echelon form, the first non-zero entity in each row. So in this first row the non-zero entity is a 1, first non-zero entity is a 1. In the second row the first non-zero entity is a 1. In the third row the non-zero entity is a 1. Okay, and fourth row also the non-zero, first non-zero entity is a 1. So in this case you are going. Okay, so you can say that all the 4 variables like x1, x2, x3 and x4 are leading variables in this case. Now here in this case this is okay, the first thing is fine. Then here also the first non-zero identity is coming like here, but here in this case for the third variable there is nothing coming in that particular fashion. Okay, only for the fourth one the first non-zero entity is coming like 1. Okay, so you can say that x1, x2 and x4 are kind of the leading variables, and x3 doesn't have a column like that. So columns that doesn't have a leading variable, here it doesn't have, it should have been a 1. If it would have been a 1, it would have been a leading variable. So columns that doesn't have a leading variable is known as they have a free variable. That's why x3 is a free variable. So that means that since there is one free variable, it's written as 1. The option is B. Okay, and the second one is like A only, since from this thing it's like rank of A equal to rank of A augmented B, but it's less than the number of variables. So okay, so it has infinite number of solutions. So I think everyone is clear with that. Now for what values of A are matrix A not invertible? So how can you find this out? First thing you can do is like to find the determinant. Okay, so if determinant equal to 0, just you can put and you can find it. So determinant of A, you will get like A into A plus 3 plus 2 equal to 0. If you give, you will be getting like A square plus 3A plus 2 equal to 0. Aishwarya is putting B and C. Yes, those are the right kind of values. So A values will be coming like -2 and -1. The options will be B and C. -2 Pavani, just check again. Just you can use the calculator. Okay, so that is also true. Then which among the following is true for the determinant of a matrix? I think the previous question is clear for everyone. It's very easy. The second one, which is for okay, which of the following is true for the determinant of a matrix? This you can tell everyone. Is it like determinant of a diagonal matrix is the product of its diagonal entries, or if one row of a matrix is a scalar multiple of another, the determinant is okay, A is right. Okay, fine, that is fine. Then A and C. Okay, that's fine. Those are the two answers. Okay, So I hope there is nothing to be explained here. A and C also will be coming, right? If one row of a matrix is a scalar multiple of another, that means that the rows are dependent, right? So those who are answered A, just check that if you have like 1 2 and 2 4 there, and if you find the determinant, this is like row, so it's like row 2 is a scalar multiple, right? 2 into row 1, right? If you find the determinant, it is 0. So answer is A as well as C. For those who are given only A, just I am mentioning this one. Any questions? I hope it's clear, okay? Okay. So another question is like, if any doubts you can ask, okay? So let lambda 1 equal to 1, lambda 2 equal to 2 be the eigenvalues, and v1 equal to 2 minus 2 and minus 2 transpose, okay? v2 equal to 3 1 transpose. Just I'll write those things. Lambda 1 is given as 1, lambda 2 is equal to 2, then v1 vector, those are the eigenvectors, so it is like 2 minus 2 transpose, it will be coming like this one, okay? And v2 will be like 3 1 transpose, that means 3 and 1, okay? We are asked to find okay, B is given like a projection matrix as v1 and v2. So B is right now, this you might have seen in your lectures, okay? Just go through that. So 2 minus 2 and 3 1 is given as a projection matrix. We have to compute B inverse A B, okay? So you might have earlier learned that if you have a matrix A, it can be written in the form of P inverse PD, P inverse you can write. So here right now what I have written here, P denotes B itself, okay? P here is like B, okay? So a real matrix A having these things like eigenvalues 1 and 2 and vectors like this can be written in the form of B, D and B inverse, okay? Like this you can write. So right now B is also given and D will be the matrix formed by the eigenvalues. D will be the matrix which are formed by the eigenvalues like lambda 1 0 and 0 lambda 2. So that will be like 1 0 and 0 2, okay? So that is given. Then P equal to 2 3 minus 2 and 1. So usually you can write in this way, okay? If it's given, if lambda 1 and lambda 2 are given and the vectors are also given, so it's usually written as P, which is a combination of the eigenvectors, and D, which is the eigenvalues, you can write in this way, and B equal to P in this particular case, okay? So what you can do, this is like A equal to P inverse dP. So if you do like P inverse into A, then it will be P inverse into P into D into P inverse, okay? Then again, if you multiply with A, P again, then in this region it will be like P inverse into P. So both these things will be coming like identity matrix into D into an identity matrix, okay? So what will be remaining at the end? P inverse AP will be like, so P inverse AP will be like D, okay? Or here P inverse, here P is equal to B, right? So that means B inverse AB equal to 0, sorry, not 0, D. So D is given by D, okay? D is given by 1, 0 and 0, 2. So this is the answer. Is that understood for everyone? Just you can. Okay. Eigenvalues and eigenvectors. Okay, like so. Okay, just wait a moment. So here, if you have a vector A, okay, A, you have a vector, okay, then A, if you find determinant of A minus lambda into I equal to 0, okay, these will be the lambda will be the eigen, known as the eigen values of vector A, okay. These are in the matrix operations, okay. Then so if you find out, I mean you have, if you want to find out the eigenvalues, it will be like A minus lambda A, determinant of A minus lambda I equal to 0, that will be the eigenvalues. Solving that, you'll get the eigenvalues. Then if you give like A minus lambda I equal to x and solving, A equal to lambda x you give, okay, A equal to lambda x you give, and the values you obtain from this one is known as the eigenvectors, using that values, okay. Neil, I'll come to a question with that, okay. We have a question like if you solve for Ax equal to lambda x, the values of x you will be getting will be the eigenvectors, okay. Just wait some moment. I have a question to find out the eigenvalues and eigenvectors, okay. There I'll explain that. Is it okay, Neil? Okay, yeah, it will come right now. So okay, now next one, which among the following are eigenvalues of matrix A? So anyway, you know the procedure to do that. Eigenvalues of matrix A can be found out by finding the determinant of A minus lambda I equal to 0. So A right now here, this one is a 3 by 3 matrix, okay. So just what I'll do is that we'll leave these questions for solving in RStudio, because okay, you can solve it finding the determinant also, but we'll see it later. First I'll move on to that question which was asked, okay. So here maybe I think we can check that one. Just I'll take a question now, okay. Okay, from here in this question itself we can try. So I'll come back to the other questions later. So here, just let me, yeah. So here you can just see like 1, 2, 3, 4 or 4, 3 are given there, okay. So which among the following can be eigenvectors? So first you have to find out what is the eigenvalue. So A minus lambda I, determinant of a minus lambda I equal to 0 you have to do. That means a is 1, 2, 4, 3. So Neil, you can just see here right now, a minus lambda is just a variable that represents the eigenvalue, and I is given there 0, 1, sorry 1, 0, 0, 1, and I am giving it determinant. I'm finding the determinant of these values. So it will be like 1 minus lambda, 2, 4, and 3 minus lambda. So determinant of this will be like 1 minus lambda into 3 minus lambda minus 8 will be coming, right? So 3 minus lambda minus 3 lambda plus lambda square minus 8. So it will be coming like, the values will be it will be like 3 minus 4 lambda plus lambda square minus 8, or it will be lambda square minus 4 lambda minus 5. Okay, this you have to, lambda square minus 4 lambda minus 5, you have to substitute it to 0 and find the values. Lambda square minus 4 lambda minus 5 equal to 0. So one person has got minus 5 and 1 as the eigenvalues. That is true. Yeah, 5 and minus 1. I hope, Neil, till this one it's not 4 and 1. Okay, the eigenvalues are minus 1 and 5. So Neil, I think it might be clear till now. Then after that, now we have to find the it's 5 and minus 1. Okay, just check once more. Just I'll also check in the calculator. So degree, so just wait a moment. 1 minus 4 and minus 5, so it's 5 and minus 1. Yeah, it's 5 and minus 1 only. So okay, so just I'll take something. Okay, so now we have to find out the eigenvector. So first we'll take the value lambda equal to 5. Okay, and for that we have to find a vector which satisfies the function lambda, equation ax equal to lambda x. Okay, this has to be satisfied. That means that a is right now 1, 2, 4, 3. Okay, and a is right now 1, 2, 4, 3, and x I can give like x1 and x2, and lambda value is like 5, so it will be like 5x1 and 5x2. Okay, then we have to solve this equation. So x1 plus 2 x2 equal to 5 x1 will be coming, and 4x1 plus 3x2 equal to 5x2 will be coming. So if you solve both these equations, you will be getting like x2 equal to 2x1. Okay, yeah, somebody had already written a and d. Okay, let me see. Yeah, so then it is like, so just look at the options. Okay, so it is like, if x2 equal to 1, just we will see, if x2 equal to 1, then x1, if x1 equal to 1, then x2 will be 2, right? So one of that options is already coming, 1, 2. Okay, so a can be given. Then we will see for lambda equal to minus 1. Okay, then in the same equation ax equal to lambda x will be giving. That means 1, 2, 4, 3, and x1 x2. Yes, somebody is always, yeah, d will be coming. Yes, that is true. So just for the explanation, I am just putting this here. Okay, so it will be coming like minus x1 minus x2, putting the lambda value as -1. And solving for this one also, it will be like you have to solve these equations, x1 plus 2 x2 equal to minus x1, and 4x1 plus 3x2 equal to minus x2. Solving this one, you will be getting like the other thing is like -1. So just if you just check here itself, it is like coming 2x1 plus 2x2 equal to 0 will be coming, right? That means x1 equal to minus x2. That means that if either of anything, so like if x1 equal to -1, x2 will be 1, and if x1 equal to 1, x2 will be -1. So in here the equation which suggests that one of the things that comes equal to this one is the fourth option. So A and D are the eigen vectors. Okay, so Neil, are you clear with eigen values as well as eigen vectors? Okay, yeah. Now we'll go back to the earlier equation. So you don't have to solve this everything, okay, every time also, because for this equation it's like, for this question it's like 5 8 16 4 1 8 minus 4 minus 11. Okay, so anyway, since your exam is going to be a written exam, here what you have to do, you have to like put 5 8 16 4 1 8 and -4 minus 11. Okay, one person has already put D, minus lambda into I you have to put here. So I here will be 1 0 0 0 1 0 0 0 1. Okay, so for this question what I'll be doing, so you can solve this and get the answer. I'll show you another thing also for this particular equation, because I'll just go to the R studio also. So here question 8, okay, this is the question 8 I have given. So I have just put the matrices here, 2 5 8 16. So you can see here, sorry, not this one, this one, 5 8 16 4 1 8 -4 minus 11. So here you can see 5 8 16 4 1 8 -4 11. I just formed a matrix with that, okay, giving like number of columns equal to 3 and by row equal to T. Then I am putting like EV equal to eigen of QA. Okay, just I have named matrix as QA. Okay, so it's like QA equal to this matrix. Okay, then I am putting like vectors. I'm just giving a name. Okay, vectors is like, I have already given EV equal to eigen of QA. So for running this one, I want some packages right now which is there, so no problem. So EV equal to eigen of QA, then I am just giving like EV of values. So right now I'm stored in EV, right? So EV dollar values will give you the eigen values. Okay, so you can use that method A minus lambda I, determinant of A minus lambda I, to get the eigen values. In R studio you can directly form the matrix and give EV equal to eigen of QA, you will get the eigen values. And if you give like EV dollar vectors, then you can obtain the eigen vectors. But eigen vectors will be like, there can be different options also. Here it is coming like something which is not, which you can't clearly write, like point values, float values are coming, right? So eigen values you can use the other method itself to find, that will be better. Now you won't be given access to R studio, okay, as of this. In the previous courses and all, you had to solve with this one, okay. So only the problems which like can be solved without the access of RStudio will be given. Okay, so here I'm just telling you the options, since RStudio is also there. In the weeks which are coming, we'll be using RStudio more. Okay, but then also you need to know how to implement that in RStudio. That is required. Okay, so then 9th question, find the nullity of A. Okay, so this also we know the answer to this one. Like, you can just find out the rank of this matrix, right? And if the rank is less than the number of variables, you can find the nullity. So directly from this one you can find out, like, some people are telling as the nullity as 2. Okay, so there are many methods to see that, so I have just given that in here also. Just I have written that matrix. Okay, and I have found out the rank. So this is 1 minus 3 minus 2. Some people are giving answer as 1. Okay, anyway, this is our matrix. Okay, 1 minus 3 minus 2, 4, 1, and just increase the size. This is our matrix. Okay, C equal to 1 minus 3 minus 2, 4, 1 minus 3, 1, 1, 0, and 0, 1 minus 1. So this is our matrix. If I run this one, you will get, I have named it as QB. This is our matrix, and then directly I can find the rank of QB. So rank of QB is given as 2. So another thing you have to see is, like, you have to install this library. Okay, library pragma, usually for finding the rank. So this library should be included while you are finding the rank of a matrix. Okay, now, so if you have got the rank as 2 and the number of variables as 4, right now 4 are there, no? So the nullity can be like 2. Okay, is that okay? So it's like rank plus nullity equal to number of most of the questions will be given like correct to 2 decimal places or something will be given. Okay, Aishwarya, in the question itself will be asked, like, you have to give the answer correct up to 2 places of decimal or something like that. Sometimes if you are getting correct 2 as the answer, then no need to put the float value also. Okay, just if they are mentioning like you have to make it closer to this much decimal points, you can write like that. So Ravi, like, it's like this is not a square matrix, right? The number of rows are 3 and number of columns are 4. So it will be like the number of variables here will be, right now you can see like which is the highest number. Okay, so then the next one is like A equal to -1, 2, 2. Suppose the eigenvalues corresponding to A transpose are A, B, C, then find the value of AB plus BC plus AC. Okay, so A you have, just I will, okay, so here you can see it like so I have A and A transpose, and we are asked to find the eigenvalues. So eigenvalues corresponding to these matrices are given like A, B, C. Okay, so we have to find out the value of AB, B plus BC and AC. So just you see, just we can try what will come when we multiply A with A transpose. Okay, so A with A transpose will give you some matrix. So this particular matrix, if you are multiplying, it will look like something like this. Okay, -122 is the one of the matrix, and the other matrix will be written as -122. So the answer will be coming like 1 -2 -2, then -2 4 4 4 4 and -2 4 4. Directly looking at this matrix, what can you see? Is there linear dependency or not? I'll name this new matrix as B. Okay, yeah, so B is this one, so determinant of B will be coming like 0. And how many rows are R3 and R2 are dependent, like, yeah, so R2 will be like, if you see, R2 is like -2 into R1. okay, R2 equal to -2 into R1, and R3 also is like -2 into R1. okay, so since both are linearly they are dependent, what will happen is that only one eigenvalue will be non-zero. okay, the other eigenvalues λ2, λ3, or in your case it is like either one, A will be non-zero and B comma C will be 0. So in that case, what will happen to this particular thing? This will be, anyway, two of them are 0, so this will be 0. yeah, so the answer here is 0. okay, I hope that's clear. Okay, I think that's clear. If anyone has any doubt, you can ask. Vaidik has still a raised hand. Is it for any question or? Okay, yeah. Okay, just wait a moment. Okay. Now, so we'll move on to the next one. Find the rank of the matrix. So this is like, just you have to see whether there is a linear dependency or linear independency, anything. okay, so 1 2 3 2 3 6 4 5 9, are they linearly independent or dependent? Okay, rank equal to 2. Which one is linearly dependent then? R2 and R1 are dependent. Are they dependent? Aishwarya, just check once more. It's 2 3 and 3 2. Everyone is giving the value 3. okay, yeah, there's those are linearly dependent columns only, and the rank will be equal to 3. okay, like, because they are linearly independent. And another thing is, like, if you just find out the determinant also, the value will be coming like around 3, I think. The value will be coming around 3. Determinant of 3 then means it is like not equal to 0. Okay, yeah. So rank of that matrix will be 3. So the answer is 3. Now let M be a 2 by 2 matrix with trace equal to 4 and determinant equal to 3. Find the eigenvalues of M. Okay, so M is given like a 2 by 2 matrix. 2 by 2 matrix, and trace will be like is given as 4. Okay, so trace will be like sum of the eigenvalues. Okay, it's equivalent to the sum of the eigenvalues, so you can give lambda 1 plus lambda 2 equal to 4, and determinant of A will be like product of the eigenvalues, that is given as 3. So just solve for this. Okay, so solving for this meaning like lambda 2 you can take like 4 minus lambda 1, and if you substitute in this one, lambda 1 into 4 minus lambda 1 can be obtained like 3. So it will be like minus lambda 1 square plus 4 lambda 1 equal to 3, and the answer will be lambda 1 equal to 3 comma 1. Lambda 2 will be like 1 or 3. Okay, so you can say like if the value of lambda 1 equal to 1, then it is like lambda 2 will be 3, and okay, so D is the answer. Okay, didn't have to do like this. Yeah, okay, so I hope that's clear. Now this we had already seen last time. Now A equal to minus 1 2 2, suppose the eigenvalues corresponding to A transpose are A comma B comma C. Find the value of AB plus BC plus AC. This is the same question. Okay, we have seen earlier. So this is like from 11 onwards, these are the questions from Jan 2023 session. Okay, ma'am, it's possible for only 2 by 2 for, yeah, these properties are possible. Yeah, for 3 by 3 you can see the properties for that one. Okay, just check that. Okay, this we have found out. Check if the following set of vectors are linearly independent. Just the usual steps to do that. Like you can first write like 2 minus 1 3, 1 1 minus 2, and 3 minus 3 8. So this is like, you can find out the answer, right? Just find out the determinant. So it will be coming like 2 into 8 minus 6 minus 1 into, or find out whether there are any dependencies there in the columns. Okay, so just you can see like minus 8 plus 9 plus 3 into 2 minus 3. Okay, so it will be coming like 4 minus 1 plus 3. So I think here it is minus, here it's minus, so answer will be what will be the answer you're getting? Ravi, the determinant will be 0, right? Linearly dependent, yeah. So answer is like the vectors will be linearly dependent. Okay, the matrix, so if the matrix A is given like this, the determinant is coming like determinant of A equal to, determinant of A is coming like zeros. That means that they are linearly dependent. Saurabh, it's fine, you can just go through the lecture sessions, okay, or just see some lectures on linear algebra, okay, how to do the row reduction, how to find out the matrices, how to find the determinant, how to find the linearly independent rows. Fourth question of assignment 2, Aishwarya, we can't discuss the present week question, okay, till its submission date. Are you meaning like today's fourth question? If it's your present week question, okay, we are asked actually to discuss the previous assignment questions, okay. So the present assignment questions you have to solve yourself. Is it that one or any previous assignment question? Okay, just what is the question, you can just tell me. If it is there in the set of questions, I can show it to you. Okay, anyway, we'll check that later. Okay, next one is which of the following set of vectors are orthogonal, okay. Saurabh, first you can watch the lecture videos here, okay, and then just take a course. I think you can learn from YouTube itself, okay, depending on which language is comfortable for you. Just do some basic course on linear algebra, okay. Saurabh, first anyway see the lectures of the present weeks so that you can catch up, okay. It's going like from the basics itself. Linear algebra videos by Swam, I haven't seen like that. Just check if it's you can understand those videos, and then maybe you can go with that. Right now I don't have any channel. If someone does know one, you can just tell, okay. Okay, just or you can, I'll just find out if some channel is good. I'll tell you next week, okay. Right now I'm not very sure about if anything is there. Okay, Aishwarya, C and D, which of the following sets are orthogonal? Okay, so yeah, dot product. So just we will go through it, okay. So 1 minus 1 minus 2, 2 0 1, 1 1 minus 1 minus 2, 2 0 1. Okay, these are the two vectors, so it's not just like dot product. It is like you have to see like yeah. So the first one, if you just check that, the first one will be coming like this one. So it you can just take like 1 minus or 1 minus 1 minus 2 and 2 0 1. If you multiply that, it will be like taking the dot product. Okay, so here you will be getting like here you'll be getting like 2 0 and minus 2. It will be 0. Okay, right, this answer will be 0, right? First question answer, first option will be 0, right? 0, right? Everyone just check once. Yeah, then second one, it's like second one yeah, okay, so this one, second one won't be coming minus 1 minus 8 plus 8. The answer will be coming like minus 1, so not equal to 0. Then the third one will be like if you give like minus this one and into minus 2, the answer will be coming like, okay, dot product you can take like this, one vector transpose into the other vector. Okay, so minus 2 minus 10 plus 8, like this you are getting, right? Minus 2 minus 10 plus 8, so answer will not be 0, right? Then another one, 5 minus 2 3 and minus 2 4 6. It will be coming like minus 10 minus 8 plus 18, so it will be 0. So A and D is the answer. Check once more. Yeah, Aishwarya, just check once more. Okay, A and D, A and D are the answer. Okay, then I think that's clear. Suppose the eigenvalues are given like this one, then the determinant of the matrix A inverse transpose is, okay, so eigenvalues are given, determinant we have to find, determinant of A inverse transpose we have to find. So we know that determinant of A, if the eigenvalues are given, will be given like 3 minus 3 into minus 4 into minus 4 into minus 3. Product of eigenvalues will be the determinant of A. Okay, yeah, product of eigenvalues. Okay, so product of eigenvalues, this will be coming like 12 into 12, right? 144 will be coming as the determinant of A value. Then determinant of A as well as determinant of transpose will be equal. Okay, so just if I am naming it as lambda, then determinant of A transpose also will be lambda. Okay, now for going into inverse, determinant of A inverse will be like determinant of A inverse will be like 1 by lambda, and determinant of A inverse transpose then also will be determinant of A inverse transpose will also be then 1 by lambda. That means 1 by 144 the answer will be somewhere around this one, 0.0069. Yeah. Okay. So answer will be point. Yeah. 0.0069. Okay. Now some extra questions. Trace of a 3 by 3 matrix is 9. A has an eigenvalue 9 and multiplicity eigenvalue 9. Then find the determinant of A. This is like straightforward question only. Lambda 1 plus lambda 2 plus lambda 3 is given as 9, and lambda 3 is given as minus 9. Okay, it is like multiplicity 1. Okay, I have missed that. Then determinant will be lambda 1 into lambda 2 into lambda 3. Okay, so I think this is fine. I have written the answer also. Determinant. So first it was like trace was given, then 2 even values is like multiplicity 2. A has eigenvalue 9 of multiplicity 2. So that's why I have taken like 9 and 9 as the eigenvalues. Third value I had taken like this one. So the third eigenvalue came like minus 9, and then determinant of A will be product of the eigenvalues. I got minus 729. Now which of the following set multiplicity? Multiplicity is like repeating eigenvalues. So here it is like A has an eigenvalue 9 of multiplicity 2. That means A has 9 repeating twice. Yeah. Now, which of the following set of vectors is or are orthogonal? So this one is like the earlier question itself we had done. Okay, but here the vectors are given like v1 equal to 5 minus 2 3 transpose and v2 like minus 2 4 6 transpose. Just then what you have to do is like a dot product you have to find. Dot product will be obtained like either v1 transpose v2, okay, or v2 v1 v2 transpose v1 you have to do. Okay, so v1 transpose v2, if you find for any of these things you can find the answer. Just like it's similar to the last question, so you can find out the answer. Just I'll give you a moment to find that out. Just everyone can check that. Okay, just the operation to be done is like v1 you have to already, it's like transpose. Okay, transpose v2. One of the example I'll show you, like it's written v1 equal to 5 minus 2 3 and v2 is minus 2 4 6. So v2 is minus 2 4 6. Okay, on example I'll show. So it's like v1 transpose into v2 you have to find. That is like 5 minus 2 3 and minus 2 4 6 you have to find out. Okay, so it will be, this one will be coming like minus 10 minus 8 plus 60 plus 18. So the answer will be 0. Okay, so that will be the answer for that one. Okay, so similarly you can check everything. So one has given A. Okay, we will see that. Okay, so one has given, has everyone got the answer? A, C. Okay, wait a moment. Okay, C is also fine, and then yeah, A and C will be fine. Then the other one, no. Okay, so the answer will be A and C. So that's fine. Yeah, you have got the answer. Okay, so next question, inverse of the matrix M. Just I have given the answer there also. Inverse is not possible. Why? Why is it not possible? Because the columns are, yeah, determinant is equal to 0. That is also fine. You can directly see that the columns are dependent, you can tell. Okay, dependent columns. Okay, which of the following is true about orthonormal vectors? So you can say like B and D. Okay, so it's like not just orthonormal means you should have unit magnitude also. So you can say B and D. Okay, C will be, I mean, that is one of the option concerning orthonormals, but unit magnitude should also be there. That's why C option is not coming. Okay, then which of the following sets of column vectors form a basis for R4? Okay, yeah, so which of the following sets of column vectors form a basis for R4? That you can just check. So just I will take the second option right now. Second option, just see if is there any linearly dependent things are there. Okay, option A, anyway it won't be spanning, I mean R4 it won't be there. Okay, because anyway you can see that there are only 3 rows, so this one is not the answer. Then B and C you have to check. So here anyway first I'll check C. Okay, C, here you can just see that 1 into 14, 16 into 14 will be 84, 11 into 14 like that, 14 into 4 is 56. So this is linearly dependent, and here also linearly dependent, here also it's linearly dependent. So C also not an option. Okay, why C also it's not an option? Because here there is dependence. So anyway your option will be B only. Is that clear for everyone? Okay. Now, how many solutions does the system of linear equations have? So just we will write 15, 20, 25, 21, 28, 35. Okay. So this is the thing. Okay. So how do you have to find out? Anyway, you know that here there are two variables, x and y are there. Okay. And what can you find out? Yeah, I have written the answer also. Okay. So it is like if you're taking 3 outside, it will be coming like 5 and 7. Then if you are taking like 4 outside, 4 5s are 20 and 4 7s are 28. And then 5 also you can get like 5 5s are 25 and 5 7s are 35. So here when you look at this, like, yeah, linearly dependent. Okay. So, and anyway, if you reduce this also, you will be getting like, yeah, so infinite solution. Okay, the answer is infinite solution. Anyway, I have written that also. So in this one, just we will go through this one. Given matrix minus 31, 12, 12 and 14, the eigenvectors are. Okay. So the characteristic equation A minus lambda I equal to 0, lambda square. So if I do that, okay, if I solve for that, it will be like minus 31 minus lambda, 12, 12 and 14 minus lambda. So determinant of this one will be coming like this. Okay, lambda square plus 17 lambda minus 578 equal to 0. From that, when you solve, you will get lambda 1 equal to 17 and lambda 2 equal to minus 34. Okay, now we have to find the eigenvectors. Okay, so initially the vector will be seeing like this one. Okay, anyway, so just we have to put lambda 1 equal to 17 first and then solve for ax equal to lambda 1x. Then we have to give lambda 2 equal to minus 34 and have to solve for ax equal to lambda 2 into x. So solving this one, we will get the eigenvalue for minus 34 as minus 4 1 and the eigenvalues for eigenvector for eigenvalue 17 as 1 4. Okay, just you can take a moment to see if the answers are coming. Okay, just we will okay, I think you can go through this one later also. So what I'll do is like I'll quickly go through the so this one, another question is this one. Consider the matrix A. The columns of matrix A forms a basis for the null space of another square matrix B. find the rank of matrix B. Okay, so this is the matrix which is given. Minus 9, 3, 8, 3, 8, 7, 8 minus 5, 6, 6, 5, 8, minus 3, minus 5 and minus 9. So you can see like the rank of the given matrix is 3. Why? Since the columns of the matrix A form the basis for null space of B, so it's like anyway you can obtain here as 3 only, the rank of the matrix. And another thing is like it's written that columns of matrix A forms null space for another square matrix B. Okay, so then since the columns of matrix A forms the basis for null space of B, you can tell like the nullity of B is equal to 3. Also there is like null space of B into Y should solve the equation by equal to 0. Null space of B of Y should solve this equation. Okay, since the basis of null space of B is of the size 5 cross 3 and B is a square matrix, then B should be of size 5 cross 5. Okay, so according to the rank nullity theorem, number of columns is equal to rank plus nullity. So here rank equal to 5 minus 3 equal to 2. Okay, so first it's like we have to find the rank of the matrix A. Then we have given like columns of matrix A forms the basis for null space of another square matrix it is given. So it is like there also that nullity will be equal to 3. Okay, so then B, if it's a square matrix, then it should be of size 5 by 5. So already we have nullity equal to 3, then rank will be 2. Okay, so what I'll do is like now I'll just show you the R implementation of some of the problems. Okay, so first one, the question 1 we had. So in between in the present questions, any doubt you have, you can just tell. Otherwise we will see the R implementation of some of the things. Repeat which question? Just wait a moment. Okay. So here it is like yeah, okay. So right now we have matrix A, and matrix A is given like this one. Okay, so just since it's a 5 by 5 matrix, since it's like a 5 by 3 matrix, okay, anyway its rank will be the highest rank with, even if the columns are all linearly independent, will be possible only as 3. Okay, the rank will be 3 only. You can give it to the R Studio and find out the rank. Okay, or you can reduce it and find also. Okay, so anyway it will be 3. So there is one property, like it is said that the columns of matrix A forms the basis will be like a base of which from which the other matrices will be formed, right? So columns of this matrix A will form the basis for null space of B. Okay, so this you have to see the lectures, okay, to find what is the null space and all. So it is given like the nullity of B, so it forms the columns of B is forming the null space of null space basis of B, then that will mean that nullity of B will be 3. Okay, so we have got the nullity. Now we have just to find just the rank of B. Okay, so usually it is like null space of B of Y should solve the equation. If it's a null space, it should solve the equation By equal to 0. Okay, that is one of the thing. So now we have basis, since it is formed from the, we have said like the basis of null space of B is formed from the columns of A. That means that columns of A has the size 5 cross 3. That means that the null space of B will also be having the size 5 cross 3. Okay, now B is said as a square matrix. We have got like the null space is like a 5 by 3 matrix. Null space of B is of the size 5 cross 3, and we know that B is said as a square matrix in the question. That means that B is 5 cross 5. Okay, so it is a square matrix. B is a square matrix of size 5, and null space is given like this one. That means that null space of B means the rank of that thing will be or the nullity. Okay, the nullity of that B will be, that null space of B will be 3. Okay, nullity is 3, that we have already mentioned, and we know that this is like a 5 by 5 square matrix. So 5 by 5 square matrix, we don't know the other, what the other rows are, because only the 3 of the columns are forming the basis. We don't know the other 2 columns. Okay, so 3 columns are like minus 3, 8. It will be forming like this. Okay, the null space of this one will be forming like this, and using this one there is the B matrix formed. But B matrix, in this B matrix only these 3 rows. Okay, another 2 rows are also there. It can be dependent or linearly dependent, but anyway we now know that the nullity is formed by this particular thing. Okay, nullity of B is 3, that we will know, because why? The basis of this one is formed by this one. So we know the nullity is 3, and we know the number of columns will be 5. So 5 minus 3 will be coming as the rank. Okay, that is the thing then. To know more about this, just go through the lecture on null space and all. Okay, yeah. Now I hope I have covered most of the things. Okay, yeah, then if any other questions I have missed, I'll take the next class. Now I have just given the many operations you can do with the help of matrices also. Like for example, this was the first question, A equal to minus 2, 4, 7 minus 2 and 3 minus 6. If you are forming a matrix, okay, so just I have given these lists. So I can give like matrix of data equal to C, ABC, n row equal to 2 and n column. Then I'll be entering this one. So matrix A, this was the first question. Okay, I think this was the first question. Now if you give like rank of mat A, then it will be 2. Okay, now question 8 and question 9 and I have given, and this was another question like to find out the eigenvalues. Okay, so these I'll be sharing with you. Now another thing will be like, yeah, to find the inverse of a matrix, or what can you do for if something is asked like that. Okay, now for this one, if you say like, so this is another example. Matrix A is given like this. Okay, so matrix A looks like this one, 1 1 1 2 3 4. and B is given like 7, 10. Okay, now if I give like x equal to solve of A into B, that will be coming like here 1 comma 2. So it's based on another question which was given in, I think, in a practice assignment, I think. Okay, so this is one thing that you have to see, like if it's given like percentage star percentage, it means that matrix multiplication. Okay, and T of A will denote the transpose of a matrix. Then inverse, finding inverse, that equation is just given for some example. Then is there anything extra? Eigenvalues and eigenvectors you can find, like A equal to matrix 2 by row equal to true. Then I have told this, right? Then transpose like this. Determinant you can find out by giving det of A. Okay, then rank of a matrix you can find out with rank of A. Okay, so yeah, then some other thing, like okay, if I run this particular thing, then A is like this one. Okay, 135. Okay, so if I give solve of A, it can't be done because this matrix is singular, because there are dependent columns. Okay, that's what it's telling. The error has come like that. Just wait a moment. Yes, so then okay, this is like a package that has to be installed for finding out the rank and everything. Okay, now again just so adding two matrices, I'll just share this file with you. There are two ways in which you can add two elements in a matrix. Okay, like creating like a for loop, if you have then you can store it with that, or you can use the plus operator also. Okay, directly like B plus C you can do. Likewise, our program to subtract two matrices B and C given like that, first you can, I have shown with the help of a for loop. Okay, that same thing you can do with the help of a minus operator, and just if you directly print B minus C, you will be getting that. Then multiplication, both kinds I have shown, like B equal to, so if I just run these two, and B is this one, C is this one. Okay, and if I give like just B into C, the answer will be like B, the elements in B multiplied with the elements of C. Okay, it's not matrix multiplication, it's just like whatever elements, the corresponding elements in the each columns will be multiplied. But if I give like percentage star percentage, it will be coming like a matrix multiplication. But here in this case it was like the matrix was 1 by 3, so 1 by 3 into 1 by 3 won't be conformable. So what you have to do is just you have to find the transpose of B, and then if you do, you will get the matrix multiplication. Okay, now similarly you can do the division also. Then matrix cross product, if you want to find out, there is also like a function known as cross prod. Okay, so these are the different things that is present, so I'll be sharing this one also. Okay, so I think today's session we can stop now. Yeah, any doubts regarding all these things you can ask. Okay, thank you. So any doubts you can just message me, or in the discussion forum also. I'll be going through the present week session also. So just if you are not getting it anything, I think in the Google Drive link my mail ID will be there, right? So you can message me. Good reference for our, that I'll find and tell you next class. Okay, Ravi? Okay. Yeah. So everyone, thank you. Have a nice rest of the day.